Okay guys, Mr. Martin back with sections 2.2 and 2.3, logic and conditional statements. So in this section we'll learn a bunch of new notation. We have P, Q, and R and so forth. As lowercase letters we will use to represent verbal statements. We have the forward-facing arrow that we use to imply for a conditional statement. We have the double arrow that we use for a biconditional statement. We have the tilde to negate a statement, and we have the three dots, which mean therefore for the final step of a logical statement. Now we won't use this for this section, but we will use it when we get to proofs. We have the inverted V that we use for the intersection of two statements, meaning that two statements happen at the same time. And we have the V, or the union of two statements, meaning that one statement or the other statement happens. For this lesson, we will use statement P is an angle is acute. Statement Q is the angle's measure is between 0 degrees and 90 degrees. Statement R is the angle's measure is between 90 degrees and 180 degrees. Statement T is an angle is obtuse. And all of this is based on the fact that A equals 74 degrees. If an angle is acute, then the angle measure is between 0 degrees and 90 degrees is the statement that we will refer to throughout the lesson. So a conditional statement is an if-then statement that always contains a hypothesis and a conclusion. The hypothesis always follows the if, and the conclusion always follows the then statement. So for our statement, if an angle is acute, then the angle's measure is between 0 degrees and 90 degrees. The hypothesis is only an angle is acute, and the conclusion is the angle's measure is between 0 degrees and 90 degrees. The proper notation is P arrow Q, which means that statement P implies that statement Q will happen. Typically, we do not use the word implies, we only use the forward-facing arrow. The truth value. So for a statement to be true, the hypothesis must be supported by the conclusion. If the conclusion does not support the hypothesis, we say that statement is false. Or if it's not a logical outcome of the hypothesis, we say that statement is false. So for our statement, if an angle is acute, then the angle measures between 0 degrees and 90 degrees. That statement evaluates to be true because it's a logical assumption of the hypothesis, and that statement, the hypothesis, is supported by the conclusion. One of those two things must happen for a statement to be true. The negation of a statement is the opposite of a given statement. We typically use the tilde symbol, which is found below the escape key if you press shift. We use that to negate a statement. So for our statement P, an angle is acute, its negation is not P, which we would refer to as an angle is not acute. If our original statement had been an angle is not acute, its negation, not P, would be an angle is acute. So for statement Q, its negation is the angle's measure is not between 0 degrees and 90 degrees. For statement R, its negation is the angle's measure is not between 90 degrees and 180 degrees. And for statement T, the negation is an angle is not obtuse. A disjunction is a compound statement that separates two statements with the word or. So it's like we take a statement P and we take a statement Q and we just put or in between them. For that disjunction to be true, all that is necessary is that either statement P or statement Q is true. When we look at the statement relative to A equals 74 degrees, an angle is acute or the angle's measure is between 0 and 90 degrees, we would say that statement is true because statement P is true relative to A equals 74, and statement Q is true relative to A equals 74. If we look at the disjunction the angle is measured between 90 degrees or 180 degrees, or the angle is acute, the statement evaluates as true because statement the angle is acute is true. Notice that relative to A equals 74, the angle measured between 90 and 180. That statement evaluates as false, but again, for disjunction, we only need that one statement actually be true. A conjunction is a compound statement that separates two statements with the word and. So for a conjunction to be true, both statements need to be true simultaneously. When we look at the statement, an angle is acute and the angle's measure is between 0 and 90 degrees, that statement is true because both statements stand alone as true. Relative to A equals 74, the angle is acute, and relative to A equals 74, the angle measure is between 0 and 90. So as a conjunction, we can say that statement is true. Now, if we look at the conjunction Q and T, the angle's measure is between 0 degrees and 90 degrees, and the angle is obtuse. That statement evaluates as false because even though the angle measure is between 0 and 90, the angle is not obtuse because it's 74 degrees. So as a conjunction, we would say that statement is false. The converse of a statement switches the hypothesis and the conclusion. If we're given originally statement P implies statement Q, the converse is statement Q implies statement P. Just like regular conditional statements, a converse can have a truth value. So if we look at our statement Q implies P, if the angle's measure is between 0 degrees and 90 degrees, then the angle is acute, we would say that's a true statement because, again, the hypothesis is supported by the conclusion, and the conclusion is a natural result of the hypothesis. When we look at the inverse of a statement, the inverse of a statement is formed by negating the hypothesis and negating the conclusion. So if P implies Q is our original statement, then not P implies not Q is our inverse statement. When we look at the statement not P implies not Q, we would have if the angle's measure is not between 0 and 90 degrees, then the angle is not acute. That is also a true statement because if an angle is not between 0 and 90, then that angle cannot be acute. So again, the hypothesis is supported by the conclusion, and the conclusion is a natural assumption of the hypothesis. The contrapositive is formed by negating the hypothesis and conclusion of the converse, or you could think about it as you switch statement P and Q and then negate both. So if P implies Q is our conditional statement, then not Q implies not P is the contrapositive statement. So for not Q implies not P, we would have if the angle's measure is not between 0 and 90 degrees, then the angle is not acute. Again, that's a true statement because the hypothesis is supported by the conclusion, and the conclusion is a natural result of the hypothesis. Always the original conditional statement and its contrapositive are logically equivalent statements, meaning that they have the same truth value. So a biconditional statement is a statement that uses the original statement and the converse statement. For a biconditional statement to be true, the original statement has to be true and the converse statement has to be true. Typically we use a double arrow to show this. An easy biconditional statement is a number is even if and only if that number is divisible by 2. We can separate that into two if-then statements. If a number is even, then that number is divisible by 2. Or we could say if a number is divisible by 2, then that number is even. So we have an original statement and a converse statement. Both of those statements are true, and we can form a biconditional statement by saying if a number is divisible by 2, then if a number is divisible by 2, then a number is even. We could combine that to say A number is divisible by 2 if and only if that number is even. So when we look at statement P implies Q, we have an angle is acute if the angle's measure is between 0 and 90 degrees. We already know that that's a true statement. If we look at Q implies P, if an angle's measure is between 0 and 90 degrees, then the angle is acute. That is also a true statement. So we get the biconditional statement, an angle is acute if and only if the angle's measure is between 0 degrees and 90 degrees. That statement is true again because the original statement is true and the converse statement is true. So you guys complete this lesson quiz, bring that to class. We will check it. You only have to write the answers for the lesson quiz. You do not have to copy the questions. So for question 1, 2, 3, 4, and 5, simply copy your answer